everyone, this is video 2-19 for Wednesday 10/26. The corresponding homework is page 29, numbers 1 through 3 in the homework packet. And we're going to start this video off by just having you write down the following 3 derivatives. So these we need to memorize, and if you have a function y equals a to the x where a is some constant, a could be 2, 3, 4, 5, a could be pi, any constant a could be, then the derivative y prime equals a to the x natural log times natural log of a. Okay, this will be the easiest derivative that you'll ever do, and it's the derivative of e to the x. The derivative of e to the x is e to the x. Okay, that's the only one. That's the only function whose derivative is itself. And then also, I used to not even include this as like a formula to memorize because you could easily prove this just using chain rule. Like if you let negative x be the inside function and e to the blank be the outside function. But I think it's going to be much quicker, guys, if we just remember this. That if you have e to the negative x and take its derivative, the derivative is negative e to the negative x. Okay, so we got to memorize those. I'm going to do 4 examples, and then the video will be over. Okay, so example number 1, y equals 4 to the x. And so I just ask myself, do I have a formula for this? You can't use, just a second, sorry. Okay, so this is not of the form ax to the n, guys. I just want to be clear. This is a very different situation. When you have the form, you don't have to write this part, but ax to the n, for example, like 3x squared, here you can use the power rule because the base x is the variable. But here the base is 4 and the variable is the exponent, so don't try to use power rule for that. You have to remember that if you have a function of this form, its derivative is of this form. So I just, remember that, and then I get that y prime equals 4 to the x, same as the normal function, times natural log of 4. Okay? So just like that for example 1. Example 2, very similar. This is an exponential function. Okay, I have a base that is some constant, in this case 3, and then my variable is up in the exponent, but my exponent is not just x this time like the last example. My exponent is itself another function. So this is a chain rule situation. So I'm going to go off to the side, and I'm going to think about what is my inside function, what is my outside function. My inside function is sine of x, and guys, sometimes I notice myself putting like parentheses around the input for a trig function, so you could do it or not. I happen to like it because I feel like it just emphasizes that that's a function somehow. Okay, and then the outside function is 3 to the blank. Okay, so the derivative of the inside, we already know that that is cosine of x. And then the derivative of the outside, this is the new thing, is 3 to the blank natural log of 3. Okay? And then what goes back in the blank, what was inside of it to begin with. So sine of x, so I'll just write it nicely. So we get y prime equals cosine of x times 3 to the sine of x times natural log of 3. Okay, so there's that derivative. Now another derivative. So down here, e to the 3x plus 7, here is another chain rule situation. There's a function within another function. So I'm going to do the chart. And the inside function is 3x plus 7. The outside function is e to the blank. The derivative of 3x plus 7, that I can use the power rule on because it's of the form ax to the n. The derivative of that is 3. And the derivative of e to the blank is just e to the blank. But what goes back in, what was in there to begin with? Okay, so the derivative here is y prime equals 3e to the 3x plus 7. Okay, one more. Okay, so this one here, I feel like I have not been clear about this, but the derivative of a situation like this, so I have this coefficient negative 6 times the function e to the negative x. So I'm going to do something that I hope will help us. I'm going to go like this. Let me do a bracket, negative 6e to the negative x. All right. And then I'll put a prime on the outside. So I want to take the derivative of what's inside. And guys, if you just have this is what's called the constant multiple rule. I've never stated it exactly. But the constant multiple rule says that if you're taking the derivative of something, and there is a constant multiple, okay, that's what this coefficient would be, a constant multiple being in front of the function, the constant multiple rule says that you can take it outside and take the derivative like that. So you can take it, so you could take constant multiples outside when you're taking the derivative and then just take the derivative of the rest of the function. So this is going to be carried down next to the derivative of that. And guys, if you think about it, it makes a lot of sense because the derivative is the slope of the tangent line. Well, if you take, I'm going to talk about this, never mind, I'll talk about that in class. Yeah, I'm going to say that in class tomorrow. All right, so now I'll use my formula to get the derivative of that. So negative 6, and then the derivative of e to the negative x is negative e to the negative x. So y prime, move this, oopsie. So y prime equals 6e to the negative x. Okay, guys, there's a video, and don't forget about your homework. It's just 3 problems. Page 29, numbers 1 through 3. Okay, see you soon. Bye-bye.